Hi, my name is Jenna Blingett, and I'm going to be talking about the earthquake that happened in 2001, the Nisqually earthquake in Seattle, Washington. So there was a 6.8 magnitude earthquake from 30 miles below the Nisqually River Delta Chicago Pacific Northwest. There was one death, 400 injuries, 2 to 4 billion worth of damages. The Capitol was damaged. Seattle Tacoma Airport was damaged. Bridges, a lot of buildings. Luckily, there was just only one death, but 400 injuries. Uh, Seattle, Washington is at the center of Juan de Fuca Plate, and this also caused landslides, outage, landlines, and communications that were destroyed. They also built a tunnel after the earthquake that took over 10 years, which is now the safest place to be if there was an earthquake and it could hold potentially a magnitude of 9. I chose this location because I recently went to Seattle and it was beautiful. And to see the buildings and bridges fully reconstructed, I couldn't have imagined how it would have been when the earthquake happened. So it's definitely nice to see how everything reconstructed and how beautiful Seattle is now. So with the tectonic setting, the Cascadia subduction zone, where the Juan de Fuca oceanic plate is subducted, that's beneath the North American plate. So the Juan de Fuca movement, it moves 3.5 to 4.5 centimeters a year. The motion of the Juan de Fuca plate to the northeast with respect to the North American continental plate at a rate of several centimeters per year. The relative motion is largely made possible because the Juan de Fuca plate depends into the Earth's mantle between the North American continent. And that's a 700-mile plate boundary known as the Cascada subduction zone. So here's also an image of our plate tectonic setting as well. So our geological setting, the landforms, there's Mount Rainier, which is stratovolcano in Washington, which was formed by many years of volcanic activity. Seattle also lies on the southeastern shore of the Puget Sound, which is 16 miles from Seattle, the inlet of the Pacific Ocean. That was formed by terrain dockings that began 15 million years ago. And they have something called a Tro, if I'm not pronouncing that incorrectly. It's a low area that was formed, and over time, the water filled into the trenches during the Ice Age times. Another landform they have is the Duwamish River, and that's the largest river in Seattle. So so the Black and White River, which was two out of the five rivers that drain the Duwamish Green watershed, that joined together and formed the Duwamish River, and which emptied into the Elliott Bay. Lake Washington is also the largest lake in the King County, and that's adjacent to Seattle, so it's pretty close. And that's the second largest natural lake in Washington, with the first being Lake Kawa. So the main rocks that I found that were in Seattle is a neodymium volcanic rocks, and that's 14% covered of the area. Those rocks are the majority compared to all the other rocks, even though it is 14%. The cause of the earthquake. So it occurred within the eastward dipping benef zone of the subductive Juan de Fuca oceanic plate. And these two plates get stuck together instead of sliding by each other. These create a huge build of potential energy to overcome the stoppage. Eventually, the stoppage is overcome and the potential energy is released into the world as an earthquake. The usual spot for this happened at the subduction zone, but the stoppage can happen anywhere along the subducting plate. In this case of the Nisqually earthquake, it happened further down along the subducting plate, which caused an intraplate earthquake. Reports of the earthquake could be felt as far as Portland, Oregon, and Vancouver, Canada. And damages to structures and lifelines was correlated to soil conditions, with most damage occurring in areas underlain by loose, saturated soils. So these are pictures of the shake maps based on 49 different seismographs. And these are the triangles. And then to the right is another picture of the shake maps as well. How Cascade Mountain ranges are formed. So, block diagram showing subductions of the Juan de Fuca Plate beneath the North American Plate along the Cascadia Trench, which is the western edge of the Cascadia subduction zone. Oceanic crust forms by eruptions along the Juan de Fuca Ridge. As the Juan de Fuca Plate drifts eastward, it cools, becomes more dense, and eventually dives under the less dense North American Plate at the Cascadia Trench. Water release from the subducting slab causes the overlying mantle to partially melt, forming magma that sustains the Cascade Range of volcanoes, which are the black triangles to our left of the image. So the changes after the earthquake. So new reports that scientists had used experience to confirm new faults, which is a total of 10 new ones, and revamped the idea of how safe the structures were in the area. There was many structures damaged, but scientists say that the earthquake could not have been stronger, causing even more damage. Using the data from the earthquake, hazardous areas were identified, which were previously considered safe. They after the earthquake, they also built a tunnel, the State Route 99 tunnel, which replaced the Alaskan Way viaduct, which built after 2001, and that actually opened February 2019, so just 2 years ago. This is considered one of the safest places when an earthquake happens, and it can hold up to a magnitude of 9, which is really good. Due to the extensive damages, building retrofits for earthquakes become new focus, especially major buildings including schools and hospitals. Are retrofitted for earthquakes as well. Emergency operation centers move to more solid locations on top of solid bedrock. And Washington Emergency Management launched to warn citizens via phones, along with the Shake Alert earthquake early warning system, which will provide early earthquake detection. And to the left is a State Route 99 tunnel, and the one to the right is what they replaced that with. So that damaged during the earthquake. And that is it for my presentation. Thank you.